Alright guys, so you asked for it, so I'm going to see what we can do here. We've got the JMP over here, we've got my face up here, so maybe that'll work. Alright, I'm going to work through the density 1 data that you guys collected in lab and just show you how I would work it up in JMP. Maybe we can go over some nice fun tricks here. So I'm first just going to start off by copying these all into some columns here. We're going to use a nice neat trick here. It's going to make this metal 1. I'm going to do that for all of my unknowns here. Alright, bing, bing. Boom. It's metal 2. Just going to pre-make these columns. Metal 3. Notice that when these columns get made, they default to this data numeric modeling continuous. That's good for what I'm going for here. Some of you that use the tech manual might be thinking, oh, Jordan, you got to put these all in the same column. You know what? You're absolutely right. But we'll get to that in a moment. All right, so I'm just going to keep inputting my data here. Click, 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 click. All right, I know you guys are excited to listen to me click on things. I bet if you skip like 3 minutes into the future, you can just ignore me copy pasting all of these. Or if you want some ASMR of me just talking, you know, here it is for all time. Dr. Moore. All right, we're almost there. So, la-di-da. All right. So now let's make this big. So we've got here my 6 columns with my 6 unknowns. This is probably how you have in Excel. As you may have learned by now, this is not really a great way for JMP to work with this. If you want, you could meticulously like copy paste these and then fill in the numbers next to them. But instead, I'm going to show you a trick that we learned semi-recently. So we're going to stack these columns. Let's go to tables, stack, click. We're going to stack all 6 of our columns. Just bam, just drop them in there. I shift clicked that. All right. I don't think we need to mess with anything here. So my data, these are going to be densities. Just call that grams per cm cubed. My label's going to be unknown metal. All right. This will make a new data set here. So this is what we actually want. And you'll see how I have all my metals together. This would probably make more sense if I sorted it by this bad boy. So let's do that. Bam. And it copied all these empty rows, which I don't think are really a problem, but if they bother you, I bet we can just remake the table and tell it to ignore the missing rows. Let's try that. Yup, there it is. Missing row button. I totally previewed this, so I know exactly what I'm doing before I show you this. All right, so now we've got our much nicer set of data here. We're going to sort this ascending. And it totally did not work. So that's because down here I can see that I have rows that are not completely empty, so it didn't do those. So we're going to try a trick here. Neat trick. We're going to row select. We're going to select where, and we're going to select where it's equal to empty. So we'll just do that. That didn't work. I don't know why. Did not like that. Because that row is not empty. All right, we're going to make sure we click the right row. Then we're going to do that. There we go. Look at that. And now we'll just delete these bad boys. All right, so now our data is nice and cleaned up. We've got our 2 columns here. This took us way less effort than if we manually input a bunch of 1s, 2s, etc. So we've got kind of a couple options here, and I'm going to work through all of them just for kicks and giggles because these are things we talked about in class. So we could just start off with a distribution. We could do, we want to do by, so kind of an X almost Y column density, bam. We get all these wonderful charts. They kind of are annoying to look through, but if you alt-click the red arrow, it'll bring up all the options. If I'm just looking at my data, these are kind of the options I like. So my quantiles, my summary, my histogram, I turn off vertical, I turn off my outlier box plot, and then I turn on the normal continuous fit. All right, so there's that. Turn on our goodness of fit down there. It's not normal, whatever. Vertical, outlier, normal. Vertical, outlier, normal. And vertical, outlier, normal. I'm going to mix it up a bit. Normal, outlier, vertical. And last but not least, outlier, normal, vertical. There we go. There we go, all the fun. And I'm going to put these goodness of fits on here just for tests, but I already know that some of these are not normal, some of these are normal. Kind of fun to see which ones are which, but I'll leave that up to you guys if you're real curious. All right, so we went through all this work, we made this complicated set of graphs here, and maybe I want to save this for all of time. So the easiest way to do this is just save to data table. We can call it whatever we want, so we'll just leave it as that, and bam, now it shows up over here in our little column there. So we'll put that off to the side. That was obviously annoying. I had to go through, I had to click a whole bunch of those. It's interesting that now I can see this data set's normally distributed, and that's it, I think. I think all the other ones are, in this one. It's weird, it's got a beep beep. That's normal, why not? We can also do this analyze, so this is what we're going to be doing when we want to do hypothesis testing mostly. We're going to fit y by x. Notice that my modeling type for unknown, these red bars, that means that this is nominal data. It could be ordinal too, it would be green bars. But that's important. Nominal means that these are in categories. So it's something like unknown number 1, unknown number 2, or treatment A, treatment B, drug A, drug B, whatever. Whereas my continuous, they have that blue line, blue triangle. That means that this is continuous data. It's a number. Very important for when we go to analyze, because if we look at analyze, we have kind of these different quadrants here in our analysis table. So if I make my x value this unknown and my y value this density, you can see that I'm going to be, x down here, y over here. I'm going to be in this one-way analysis. These are box plots. These are what we want to be in. So if these are messed up and you're ending up in bivariate or contingency or something, check your modeling data. I'm going to click OK. That's going to give me this. We're going to, once again, alt-click that, and that's going to bring up this. So we're going to turn our quantiles, means. We're going to do some display options here. So we're going to keep our points. We're going to turn on our box plots. We're going to turn off grand mean. Grand mean just means it takes the average of all the averages of these guys. So if you want to know what the average density across all of the trials is, it's roughly this. I say roughly because it's a little weird. I'm going to turn off this x proportional. So you see how these are different widths? That's because this is scaling how much space they get on the x-axis by how much space how much data they have in them. I like to turn on my points jittered here. So those are my display options. If I click this now, it'll do that. It'll give me this nice lovely thing here. And in terms of making a bar graph or box plot for your density lab, this is sufficient. We're going to take this a step further though. So we're going to do some hypothesis testing here. So we want to compare means. So if we didn't know anything about our data set and we just assumed it was normally distributed, we would do this all pair Tukey. This will tell us which of these are statistically significant. So we can look at this two ways. We can either read off this, and this is comparing, metals 3 to 4 and saying they're different, 6 to 4 is saying they're different. Basically, metals 3 and 6 are the only two that are unique. We can also look at this connecting letter report. So this is saying that metals 3 and 6 are both similar. Metal 2 is different from everyone else, 1 is different from everyone else, whatever. Connecting letter means that if you have the same letter, you're the same as that letter. If you have a different letter, you're different. And things can have multiple letters too. So it's a really interesting readout. Leave that open. We'll close all this crap we don't care about. All right. So that would be if our data was parametric. If it's non-parametric, we have to do this other stuff. So we actually want to do this steal DWAS all pairs. Same thing, our data is pretty well distributed, so it doesn't matter. The only thing is that if you look at these values, the steal DWAS gave us higher p-values than this. And this will always happen when you compare a parametric to a non-parametric test, because the non-parametric test is conservative, meaning it's more likely to give you a negative result. So we have this graph. It's up to you whether or not you like it, but your TA will be judging it, so you might want to make it extra pretty for them. And I'm just going to turn off some of these. I'm going to turn off these all pair circles. I don't know where they're hiding though. Display options. I know you're somewhere. Comparison circles. All right. I'm going to show this one too because it's really cool. So this is compare density. If you want to make a histogram but you don't actually want to display the histogram, this is the best way to do it. Because look at that. This is a probability. Well, actually, I guess it's not a probability density function. I don't know what this is, but it's cool. So, fun fact, there it is. All right, so in JMP, basically everything is editable. So if I right click this background, I can go to customize, and this will let me play with all of my settings. So maybe I want to change the color of my error bars. Why do I even have mean error bars on here? These are the big questions. I see them now. So we're going to find those and we're going to turn them off because I don't want mean error bars on here. I don't want standard deviation lines. I just want these. All right. So I can go back to here. I can mess with all these. So I can change my line color. I can change my line style. We're going to make all of these look nice and pretty. Just turn them all black. We might make the lines a little thicker. And then we're going to go to our marker up here. We're going to change our marker. So we're going to leave it that. We're going to make it transparent though. So I'm going to make it 0.5 because I like it. It's pretty. We're going to do a, we're going to add our own jitter here. So we're going to center it. We're going to add some spacing there, I think. Yeah, there we go. Maybe. Can you go smaller spacing? Yeah. Now there's a box plot. All right, so this would be a dot plot. And this would be pretty acceptable for a lab. All right, now let's say we wanted to do something else. We didn't need all of this statistical power down here. We just wanted to make a pretty graph. So we can go to Graph Builder. We can put our densities once again on the y-axis, our unknown metals on the x-axis, and we can click these. So maybe you're in the group that had to do a bar chart. Bam, got a bar chart. Now remember, we went through that studio. What do we want? We want error bars. I like standard deviation. You want your summary statistics. So this is just where your your bar is. So that should be mean. You could change it to these other things, but they don't make sense. You want, let's report a mean, unless you have, we talked about it. If your data is not well described by a mean, maybe you'll report the standard deviation in the interquartile range or something, whatever. We can make our box plot again. So this one is the outlier version. I think we're gonna stick with that because honestly, I don't know how to change that here. We're gonna do the centered grid for our outliers. Pretty straightforward there. We can do our histograms. These are lined up. So here the problem is that these increments are kind of weird. So we want to change our increment to something that'll better show distributions. So I'm going to make it 0.2. So I'm pretty sure that works well. All right, let's see what happens here. Let's get rid of these minor ticks since I'm going to have so many of them anyways. All right, there we go. We have box plots or histograms, whatever. I don't think it makes sense to use any of these other forms there. So I think that's it. You know, that took, okay, I've been recording for 15 minutes. It took me 15 minutes to make all the graphs. So I hope you guys are JMP pros now, and maybe we'll make more of these. Maybe we won't. Maybe I'll get fired. Who knows? We'll see. Okay, by that I really meant we'll see right now. So I forgot to go over exporting. So if you want to save your pictures of your graphs or use them in other media, you got to export it somehow. So if we're on our graph builder here, or you can do the same thing for your fit by y by x analysis, we can just close out of this, hit done. That'll hide all the kind of interactive elements, and we can save this. If you want to bring the interactive elements back, just hit show control panel. All right, so on Windows, you hit this blue drop down, it'll bring down the file menu. You file, save as. On a Mac, you'll have to go up into your command bar, hit file, and then I think there's an export button there. It'll bring you to a similar page. On Windows, you hit the save as type, you pick what you want. On Mac, it kind of lays it out for you a lot better, but the options are the same. So if you're saving pictures, PNG, JPEG, pretty straightforward. This SVG and EPS, these are vector graphics, so they have infinite resolution. They're really good if you want to print a poster or make something that's really big, because they will scale as big as you blow them up. They won't get pixelated. You also have this PowerPoint option. So we'll do that with the fit y by x. So the PowerPoint option is really nice for this guy because when you save as a PowerPoint here, it exports all the elements individually. You can choose the graphic file format, but it doesn't really matter. So we save it, and bam, we have all of these PowerPoints. There's one thing I want to warn you guys about, which is if you export this as like an image file, it's going to export the whole thing as an image file. And that's not really a problem. I just want to head this off because you can still put this in a document, and then in the document you can crop this. So just crop out whatever you want from it. The other thing you can do, and I actually do recommend this if you're just going quick, is you can snip it. So you can use the Windows snipping tool. On Mac you can use Command-Shift-4 to bring up the screenshot tool. Whatever floats your boat, and then you just draw your box around it, and bam, instant graph. The only problem with this is that this is a really rasterized image, so however big it is here is how big your screenshot will be. So if you want to make a really nice one, then you have to find some way of like making this bigger and then re-screenshotting it. So I would recommend, I guess, using the file save as option because you'll get better quality images, but if you're just doing quick and dirty, this is fine. All right, so now we're done. Now you guys are JMP pros. I know before you were skeptical. You were like, Jordan, I'm not a pro yet. You didn't teach me how to export it. But now you know. You can save, you can export, you can snip. So take your newfound powers and go wild.